So what you can see is that we currently have our LED connected through the 3.3 volts on pin 1. What we're going to do now is change that to be connected to GPIO pin 11. Please be careful here because you'll notice that the description next to the name is GPIO 17, but I'm going to keep referring to them as the pin number, which is the inside number there, pin 11. And you'll notice that we've got a variety of different green GPIO pins labelled here. All of these ones are ones that are not assigned for other jobs and are literally for any inputs and outputs that we might require from the pins. Very irritatingly, strangely arranged in different places, and the ones that we'll be using for this project are 11, 13 and 15. So I'm going to start off by just using 11 as shown here, and I'll show you how that looks practically now. So what we can see is I've already got this pin in to number 1, and I just need to change that pin, counting down carefully, remembering that you can wire into the wrong place and cause damage to your Raspberry Pi, so just be careful where you do wire to. And this will allow us to control our LED with the help of some software that we're going to write next. So to now switch back to the Raspberry Pi's operating system, and you'll notice we've booted into the graphical user interface, what we know as a standard desktop. Now what we're going to do to start with is open a piece of software. So I'm going to go to the menu, I'm going to go to Accessories, and I'm going to go and open up the piece of software called LeafPad. I'm using LeafPad because it's very raw. It's like any other basic text editor for other operating systems, and it just shows that we can get a program running with literally the most basic of tools. So we're going to need to start to type our program. Now we're going to be using a language called Python, and we'll be going through some key commands of how that works, and hopefully we'll just get our LED to light from our GPIO pin very shortly. So we're going to start off by importing a library. So if you've not come across this before, we're basically importing code that somebody else has written to be able to use in our toolbox so that we can use some of those commands out there. As standard, we can already use a lot of commands in Python. However, the GPIO commands we're going to need aren't ready to use in Python as standard, so we need to import those in. So I just type import rpy, notice it's capital R, capital P, lowercase I, dot GPIO, because we know we're using our GPIO pins, as GPIO. And that's our first line of code done. And again, all this does is just importing that library. You don't need to fully understand the rest of what it's doing as long as you understand what it does as a whole. We're also then going to need to set up our GPIO pin and give our GPIO the mode that we would like to use the board in to help it with understanding the numbering system used. So I'm just going to type in GPIO dot set mode. Please look at the lowercase to capital case way that I've done that, and the set mode is going to be GPIO dot board. Again, you don't have to understand a lot of this, but it's just to make the point that the GPIO pins that we'll be referring to, it needs a way of knowing how those pins are set out and set up, and we use the board type to be able to refer to this. Again, it's really part of just setting up the GPIO pins and the language ready to use. In most cases this will never change as well, so it's just something you can remember if you ever wanted to. So the next step for us is to start setting up the individual pin. So I'm going to type GPIO dot, and we're going to set up a pin. And what would we like to set up? We'd like to set up pin 11, which is the one that we've wired into. And I'm putting a comma to give this function another parameter. So GPIO.setup, we tell it that we want to work with pin 11, and then we need to tell it whether this pin is going to be an input pin or an output pin. If we were going to be reading temperature from a thermometer, soil humidity from a soil humidity sensor, or light sensor, we'd need to set it up as an input pin to be able to take readings. Now we actually want to set it up as an output pin so that we can send voltage out through it. To do this, we're going to just type GPIO dot out. I'm sure you can guess how we'd set it up if it was going to be an input pin. Once we've done that, we're kind of ready to actually start programming with this pin. So to start programming with the pin, we're actually going to say, okay, well, we know that it's an output pin, but we haven't actually told it to start sending the 3.3 volts through it. So the new command we're going to use, which we'll be using a bit more, this isn't just setup anymore, is GPIO.output. And what would we like to output? Well, we'd like to output on pin 11, we'd like to make that output true. So all this says is, yes, true, we would like to send voltage through that pin, which of course it isn't in the meantime. So the next job is we need to save this. So I'm going to go File, Save As. I'm going to choose to save this on my desktop, and I'm going to give it a name of, let's call it led.py, giving it a .py extension for a Python file. I'm going to save that. Hopefully, sure enough, it appears on our desktop. So the only thing left to do now is, can we make this pin run? So to do that, I'm going to need to open the LX terminal. If you don't have this on your desktop, you will find it by going back to the menu, back to accessories, and you'll find the LX terminal in here. Now, to be able to run that program, we're going to need a couple of things. We're going to need to start off with to change our directory, and I'll show you why. You notice this tilde sign means we're currently in our home directory. There's a command we can type in the operating system which is ls, and if I hit enter on ls, what it does is it lists everything that is in the directory that we're in at the moment. So you'll notice that we have our documents in there and our desktop that's in there, a few other folders and a few other files. Such as a JPEG file, so that must be an image that we've got there. I actually need to go to my desktop to where I saved this file, so we need to change the directory. So we type CD for that, for change directory, and I'd like to change my directory to the desktop. So I just start typing desktop, remembering that desktop needs a capital D, just as it's listed here. To make sure that I'm going to get this right, I'm actually going to use an autocomplete feature that's available with most operating systems. If I hit the tab key now, it will say, well, there's only one thing that we've got that begins DES, so it auto-completed that for me. If I hit enter now, we change the directory to the desktop, which means we're in the home directory, and in the home directory we're in the desktop directory. So we can use our ls command again here to find out what is on the desktop. And sure enough, we've got a variety of different files. Some of these look very familiar to the icons we've got here, as we would actually expect. We've also got the file that we created, led.py. So we're going to try and run that now and see if our LED lights. To do this, we're going to need to type our a new command called sudo. Now, sudo just turns us into a super user. As you'll know from using computers previously, only your administrator has access to change certain things on your computer, and that's for security reasons. So that we don't have people tampering with some of the system elements that we don't want them to. Now, the same with the Raspberry Pi, we're actually already the administrator. However, to be able to use the hardware of the GPIO pins, we need to be a super user, which is why we use this sudo command, which basically gives us access to do absolutely anything. Be very careful when doing this command, because this would allow your computer to do absolutely anything, including to be deleting key system files. So you do need to be very aware when you're ever using a sudo command. So we're going to start off with sudo, and then we're going to say, well, we want to run a Python file. So I'm going to type Python. And lastly, we need to say what file we want to run. Now, we've already listed here as led.py, so I'm going to start typing led, and of course I can use my tab to complete, and sure enough it auto-completed that for me. Only thing that's left to do is hit our enter key. Oh, we've got one quick error, and it's saying name true is not defined. So I think simply what we need to do is go and change true to be lowercase. Capital T with a lowercase, rest of our writing. Just a simple typo from me there. Be very careful. I notice because the asterisk is still there that I haven't saved this up to date, so File, Save. And let's just try and run that one more time. And to do that, I'm going to use another little cheat. If I press the up arrow on my keyboard, you'll notice it can go through the old commands that I've already typed. So if I go back to sudo python led.py and hit enter once more, so as we can see, the light has lit, but we have got a little error message just telling us that the GPIO pin has already been in use, as we can see here, and that I basically never stopped using it last time. So all we need to do is add a little bit to our code as a next step, just to clean up the GPIO pins when we finish using them. It's a great start.